All right, friends and neighbors, time now for Chapter 5 in the CCNA Volume 2, Securing Network Devices. In this video, after the key topics, we'll be going through some parts of the exam section with the role of network components. Specifically, we're talking about firewalls and IPSs. Well, the part of the exam is configuring network access for remote access using SSH, but this chapter is concerned with the passwords associated with SSH. Actually, the passwords associated with telnet, SSH, enable, any real way that you're going to get to the device. And we'll finish up with the do you know this already questions. So our topics in this chapter: commands whose passwords are encrypted by service password encryption. So we'll do a demo that shows you the impact of different levels of security for the passwords. That'll be fun. Rules for when iOS uses a password set with the enable password versus enable secret. So we'll talk a little bit about the hash algorithms that go along with that. And then what does the iOS do when you have a password, right? How does it actually compute or match the hash that you've actually configured? And then the rest of the chapter is really about the functions of firewalls, and then what do next-gen firewalls bring to the table, and then IDSs, or intrusion detection systems, or IPSs, intrusion prevention systems, and then what's the next generation bring to the table. And of course, in the middle of that security conversation, we'll be talking about some zones. All right, when we talk about securing iOS passwords, what we have to remember is that when you just do an enable password, or when you just do a username followed by a password, the password is not encrypted. So if you printed off the config, or you left a console open, well, somebody could walk right up and read the password itself. So a much better approach is to use the enable secret command. Now, more on that in a second. But if we talk about enable or user login or telnet, right, we can just apply a password to those. When we configure a device for SSH access, as we saw a long time ago in one of the earlier chapters, which I'll link in the show notes, we know that there's more to an SSH configuration, right? We need a domain name, we need to do keygen, and then we've got passwords that are required for the login. And then, of course, you could specify that we want to use SSH if you just say transport input SSH, and that only allows SSH connections. And of course, the reality is that we prefer to stay away from telnet because it's clear text. Okay, so let's say that you've got all these passwords in your config file and you didn't use secret. So you've just said stuff like username and password or enable password. Well, there is a command that will allow you to say, well, let's encrypt all of those. Now, it's a little bit weaker than the more modern hashes that have been out there, but you can suddenly change all of those clear text passwords to encrypted ones. Now, it's not reversible. You can't say no to the command, right? No service password encryption and magically get the clear text passwords back, but that's not a big deal as long as you remembered your password. Now, this command is sort of lightweight. You'll see the difference. It'll be a type 7 when we do it, but that also makes this kind of easy to reverse engineer. There are whole websites dedicated, just like they're dedicated to the default passwords, default SNMP strings, default IP addresses. There are these password strings that can easily be worked backwards. So there are some better choices to make. And the first one that we talk about is enable secret. So instead of just doing enable password, we're going to do enable secret and then the password. And what that does is changes your clear text that you put in there into an MD5 hashed password. So that'll be a type 5. Now the whole point of this is to A, not make your password clear and readable. But the process to take a clear text password and turn it into an MD5 hash, or a hash of any kind, is actually pretty quick. Going backwards is much more computationally difficult. So if you have something that's been hashed, encrypted, to work backwards and find the clear text is much harder. And that's just how the algorithm works. It's sort of a requirement of hash algorithms. Now, when we think about the operation, there's two kinds of things that we want to think about. If both commands are available, right? Enable password or just enable secret. If they're both active, then the one that the iOS will take will be the enable secret. If one command has been issued, then you just use that one. If there is no enable password, then anybody coming in via telnet or SSH will be rejected because they can't get access to the box. So how does a hash work with user input? So when you're logging in, you type in clear text, and the iOS takes the hash and then does the calculation, does the comparison between its recently calculated hash and the one that's in the config file. And if they're the same, you log in. Now, just for fun, the chapter also uses the pipe command, and I'll show you that as well. So let's do a quick demo. All right, so here we've got a couple of routers. And what I'm going to do is just the enable password. So we'll just futz around with that. So if I say enable at this point, right, this machine just booted up, right? There's nothing on it. So if I just say, what are my options? Well, if I say password, this means that I'm now going to issue an enable password. Now, there's a couple things here that we want to do. We're not going to worry about the 7 at this point. We'll get there. Now, the level, that has really nothing to do with the password itself, but rather a granularity as to what this enable password will allow access to. But what we're really worried about is what happens when we actually put this password on there. So I'm just going to say the password is hi there. Okay. Well, what does that look like? Now, I could do a show run here, but the chapter also has some fun with this. So I'm going to say show run, but I'm going to pipe it to include, right? If you had a big configuration, then you might do something like this, include enable. And you can see that it just spits back the part that I want rather than, the whole config file. Okay, so you can see that this text is clear, right? I can read this. So what we're going to do now is we're going to change that password into an encrypted version of the password. So we're going to say service password encryption, and then we're just going to hit enter. And let's take a look now at the output. And we can see now that the password has been modified to a lightly encrypted version. So this is the thing that's available online, right? There are websites dedicated to working backwards through this sort of lightweight encrypted version of the password. So what is better than just doing enable password or doing the service password encryption command? Well, let's take a look at our other router. And if I take a different approach here entirely, I say enable, but now instead of doing the password, I say secret. Now, what am I allowed to do at this point? Well, I could say 5 here, but the iOS is going to take care of that for me. So I'm just going to say secret and then the password. And I'll say hi there again, and then maybe we'll do a comparison. Okay. Maybe I'll show you where this is in the regular config, right? It's right up top here, but take a look at this, right? They're the same password on these two routers, but one looks like this and one looks like this. Well, that's because this is a different algorithm. It's the MD5 algorithm that has been used to encrypt this password. Now, MD5 is still a little bit old. It's about 30 years old. In modern iOS versions, there are other hash algorithms, most notably the secure hash algorithm 256. If you were doing this configuration and you went to do enable secret and you had an updated version of the iOS, you could choose a different hash than MD5. Now, a little bit more about those hash algorithms. So hash functions must result in a single value for each clear text password. Now, this should make sense to you, right? We don't want a hash value for two different passwords to be the same. And you've got to be able to work backwards to get the clear text, but it's got to be hard to do. So those are sort of the characteristics of hash functions. Now, as I said, MD5 has been around for a little while. So there are additional hash algorithms The secure hash algorithms is the one that's implemented, but there are two ways to go about it. So you could do the type SHA256, the secure hash 256, or the secure crypt secret password, and they result in a different type. So if you were looking at the config, you would see that there were two different types and you would know how something was encrypted. Now, similarly, if you just do a username and then a password, that password is not encrypted. So again, better when you're setting up usernames, we want to have a secret password associated with that. Now, as you know, when you're setting up a router, it's probably not the best choice to put usernames and passwords on the devices. Now, people do it, and it happens all the time. When that's not in place, then what you're going to be using is an AAA server, right? So your router or switch, when you go to log in, will point out to an AAA server, then you'll be authenticated against that, and then that answer will come back, and then you'll either be permitted or denied to log in. Now, controlling password attacks with ACLs. Well, we just got done doing standard and extended ACLs. Wouldn't it be kind of cool if there was a way to control who could access a device via telnet or SSH on the line? Well, it turns out you can't. So in addition to adding usernames and passwords to those lines, you can also add an ACL that says only these IP addresses, or even only this one IP address, is allowed to access this particular device via telnet or SSH. Now the difference is that instead of using the access group command on the interface and then the direction, right? IP access group 5 in or out, you're going to be doing the access class in or out. Now the cool thing about it is that in is pretty straightforward. If the access list says in, then it's controlling access to that particular device. But if you were going to use that connection to get someplace else, and that you wanted to prevent that, then you would use the out direction to limit that connection. Now the cool thing about that too is that when you're looking at that access class, you're not looking at the source IP address, you're looking at the destination. So this is a special case where you build an access list not concerned about the source IP addresses, but concerned about the destination IP addresses instead. Well, let's do a quick demo on what that looks like. So here's our router friends again, and we'll just set up a quick access list. Access list 1 permit 192.168.1.0. So this is permitting an entire subnet. Now normally we might apply this to an interface or direction using the IP access group command. But what we're going to do instead is say line VTY, and we'll just pick a line that we want to use. And then we're going to say, what are my options? Well, right up here we see the access class. And so we're going to say access class 1 in. Now what does that look like in the configuration? We can see right here how this was applied, and there is the access list right now. All right, firewalls. Now traditional firewalls are typically placed in line with traffic, and so you want your traffic to flow through the firewall, and then the firewall performs functions similar to ACL. So that's a very traditional firewall. Now the big point here is that firewalls are different than routers with ACLs because routers are there for performance. ACLs are okay, so we apply ACLs maybe at the access layer to prevent too much traffic or unwanted traffic from flowing into the network. But what we really want is routers to have high performance. We want them to forward packets, so we don't want them doing too much packet inspection. And so that's what the firewall's job is. It's usually a separate appliance, but also we have additional capabilities beyond what an ACL does. We know that ACLs look at headers and fields and things like that and do comparisons, but firewalls have additional capabilities such as deep packet inspection, string and URL inspection, historical state inspection, something we call stateful inspection. And so again, typically a different device. Now the example in the book is that a stateful firewall might have historical data regarding the connections to a server and be able to protect the server from a DOS attack. Okay, what does all that mean? All right, so imagine you've got this server there, and you're used to a certain number of users connecting to that particular server over time. 3 users a minute, 3 users a day, whatever it is. And then all of a sudden you start to see lots and lots of connections coming in. And the goal is for this denial of service attack to shut down your server by overwhelming it with connection attempts. What the firewall might do, if it is stateful, is it might say, well, look, I've been paying attention and keeping track of the connections that are there and how many I'm used to seeing. I'm now seeing more than I'm used to seeing, and so I might act to protect the server from this DOS attack. Now, firewalls also have the concept of security zones. The security zones describe which users can initiate new connections. So, for example, inside users should be able to initiate a lot of connections, both to the outside world, the internet, or to inside services. But outside users, we don't want those coming in, or at least all the way into the corporate internal network. It's very common to have really 3 sorts of zones. Now it can be more complex than this, but generally speaking, we have an inside zone and an outside zone, and we enable or disable connections from those locations. But we also have a zone that's called the DMZ, the demilitarized zone. And the DMZ is an area of a little bit less security because this might contain servers that are accessed from the outside world. And so we have some level of protection there, but they're allowed to have connections coming in. So those are our 3 zones normally on firewalls. Now, intrusion prevention systems, they also set in the path of traffic. Now, there's a lot of times a distinction between something called an intrusion detection system and intrusion prevention system. An intrusion detection system works in many ways just like a firewall. It detects things. It reads things and understands things and then alerts somebody. But an intrusion prevention systems a lot of times can take action. So they sit in the path of that traffic, and what normally happens with an IPS is that you download signatures onto the IPS. And what the IPS is looking for is all kinds of attack signatures, all kinds of attack patterns. And when it recognizes those, it says, I'm supposed to do something about this. At the very least, it's a notification, but it might actually act to restrict traffic. Now, the patterns or the signatures that are downloaded or that are installed on the machine, and these are updated periodically, match the patterns that various exploits use. So if you're looking at a TCP SYN flood attack, that has a certain pattern. And so the signature is loaded up, and when the IPS recognizes that, it might take action to prevent it. So common signature types that we're looking for: denial of service, distributed denial of services, viruses, worms, and Trojans, oh my. And again, the vendors regularly update these signatures. Now, there is something called a zero-day attack. A zero-day attack is a brand new attack. Nobody's seen it before, nobody knows about it, and it happens. Now, the minute this attack is used somewhere, then folks go into the research room and they say, let's tear this thing apart, let's figure out how it works, so that we can develop a new signature to download into the IPS or even the firewall. But there is a delay between the time of detection and the time that we have a signature to prevent it. And that's the danger of zero-day attacks. Now, in this discussion, we're talking about network firewalls and network IPSs, but don't forget about your host-based firewalls and your host-based intrusion protection systems. Now, next generation firewalls, right, is built into the Cisco Adaptive Security Appliance, the ASA. And the product line is the Firepower firewalls. So Cisco has been doing some development, but they also made some acquisitions. And so the next gen firewall performs all the functions of traditional firewalls, but then adds additional features. Okay, so the basic challenge faced by a firewall when it's trying to prevent user access or bad guy access is that all the applications that we use, web servers and mail servers and all of that, they use well-known ports. They're easily identifiable targets. Attackers also understand the zone restrictions that are typically employed by firewalls. Attackers can also run all kinds of reconnaissance, including things like port scans, to find out where the vulnerabilities are. Now, the attackers want to use an application of their choice, whatever they're going to use to attack you with, but on a non-standard port. So, for example, they might use web service, right, HTTP service, but on port 23, where it's not supposed to be. So a next-generation firewall says, okay, I'm going to keep track of application layer data and do deep packet inspection. I'm going to look inside the packets to try and ascertain what a packet or a stream of packets, a flow, is trying to do. And in Cisco land, this is called the application visibility and control, and then the advanced malware protection. So next-gen firewalls are really trying to understand what's happening in real time. Similarly, the next-gen intrusion prevention system builds on that idea, right? It's informed by the same source fire acquisition, same product line. But one problem that traditional IPSs face is the number of events logged. So it's a really, really, really big problem. There was a study a while ago that said somewhere in the neighborhood of 50% of all IPSs fail within the first 6 months of installment because they generate so many alerts and so many events. So it's really, really hard to train an IPS. So next generation IPSs are designed to be a little more helpful with this. So an IPS, in the traditional sense, will read the signature database, right, all the things that you downloaded, generate all those alerts for all the violations, and then you get pages and pages of all these alerts. And you have to filter through them and decide what's worthwhile and what's really, really kind of garbage. So the Cisco products say we're going to gather more information about the host. We understand more about our switch and router environment. So we're going to make more informed recommendation and alerts. Now, if you want to know more about this stuff, there's a nice website out there that the chapter talks to. I went out and visited. There's a lot of information out there, and that's talosintelligence.com. All right, did you know this already? Imagine that you have configured the enable secret command followed by the enable password command from the console. You log out of the switch and log back in at the console. Which command defines the password that you had entered in the privileged access mode? And that would be enable secret. Question number 2, some iOS commands store password as clear text, right? We saw that, but you can encrypt the password using the service password encryption global command. By comparison, other commands store a computed hash of the password instead of storing the password. Comparing the two options, which answer is the most accurate about why one method is better than the other? Now remember that the whole point of a hash function is to be easy to create the hash, but hard to work backwards. And even if you did the service password encryption to get rid of the clear text, right, that is easier to decrypt than the hash function. So that was A. Question number 3, a network engineer issues a show running config command and sees only one line of output that mentions the enable secret command as follows: enable secret 5, and then that hash. Which of the following is true about the users of this router? Well, when you type in your password, you're going to type in the clear text password, hi there. And the router does the hash and then compares that to the hash that's stored. So that was B. Question number 4, a single line ACL has been added to a router configuration using the command IP access list 1, 172.16.4.0, and then 001.255. The configuration also includes the access class 1 command in the VTI or VTY configuration mode, which answer accurately describes how the router uses ACL1. So this was the indirection, so hosting this subnet can telnet to the router. Question number 5, a next generation firewall sits at the edge of the company's connection to the internet. It has been configured to prevent telnet clients residing in the internet from accessing telnet servers inside the company. A wise choice. Which of the following might a next-generation firewall use that a traditional firewall would not? And that was B, match message application data. So, right, that is the ability to look inside and see what's happening inside the packets and what actual commands or messaging might be there. Question number 6, which actions show behavior typically supported by Cisco Next Generation IPS beyond the capabilities of a traditional IPS? Choose 2. That was A and D, using host-based information, right? More information about the hosts, and filter URIs using reputation scores. So that was more details about the environment and getting contextual clues. All right, hopefully you did well on those questions. Now the Chapter 6 look ahead, we're going to be doing port security concepts and configuration. So this is taking a look at what you can do to secure a switch in addition to the passwords. What are the options? What are the violation modes? How do we do verification of the commands? What's up with the addresses that we see on a switch, and what are some of my options? So what is port security? What does it mean? How does it work? And of course, a demo. Okay, this has been Chapter 5, Securing Network Devices. We went through passwords, secret, hashes, MD5 most notably in this demo, but of course, the secure hash algorithm is out there. Telnet, SSH, we even did piping with the include statement. We talked a little bit about ACLs, right? How do they apply to V2Ys? Firewalls, both traditional and next generation, and intrusion prevention systems, traditional and next generation. All right, like and subscribe for more switch security. May those packets always reach their destinations. And hey, this is CCNA. You can do this.